Hello and welcome to the Road to Autonomy. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to welcome Mike Doucleff, Global Head, eMobility Division Schneider Electric. Mike, welcome to the podcast.
Hello, Grayson. Thank you for having me. Very excited to be here today.
I'm excited to have you here because EV infrastructure is going to play a key role in scaling EVs globally. Without EV infrastructure, EVs don't scale. Mike, you're knee-deep in all things EV. You have a great understanding of the EV infrastructure. In your opinion, what is the current state of the electric vehicle industry?
Let's start here. Let's start at really the climate imperative. Today, transportation accounts for around 27% of global greenhouse gas emissions. And if we want to reach our goal of 1.5 degrees C rise max by 2050, we need to shift the energy mix in transportation from today, which is only around 1%, to over 50% by 2050. And that's a huge transformation, around 1% of transportation today electric to 50% by 2050. Now, when we look at adoption and where do we stand today, always I'd like to start with China. China is really leading the pack across continents in terms of adoption. And that was really driven by government programs. That was really top down. That was China in one of their 5-year plans saying, we will electrify. And they started from fleets, right? So electrifying buses, 400,000 or 500,000 electric buses in China. Electrifying taxi fleets by city, all taxis, 22,000 are electric. So it's really amazing. And China has that ability to really do things big, fast, and at scale. Then if we shift over to Europe, Europe is starting to come around. A lot of that has been driven by, historically, the European focus on environment. And specifically, there's one great example, which everyone knows, which is Norway, where for over 10 years, the Norwegians have been incentivizing electric vehicles. And today, every year, over 70% of new purchases are some sort of EV or plug-in hybrid. And then if we look at the US is trailing a little bit behind Europe by a couple of years, but clearly what you've seen on the news recently, especially given the passing of the Inflation Reduction Act, the IRA, there's a huge focus in North America on electric vehicles. Now, in terms of the economics, which is something that I follow very closely, the economics of electric vehicles, one thing to look at is the cost of storage, the cost of lithium-ion battery. And the math says that once the cost of the lithium-ion battery gets to around $100 per kilowatt hour, OEMs, so automotive manufacturers, can offer electric vehicles at price parity with internal combustion engines today. So that means that when you walk into a dealership or you go online, you look right and you see the internal combustion engine, you know it works, and you look left and you see the EV. Well, the EV at some point is going to be the same price. Ultimately, it's going to be cheaper. It's more fun to drive. It's clean for the environment. That's going to switch overnight. Now, already today, it's cheaper to operate an electric vehicle. So it's 10 times cheaper to operate. So there's virtually no maintenance. The car lasts 3 times as long as internal combustion engine, and fueling it is much cheaper using electricity versus gas. Then finally, if we look at the OEMs, so now the automotive manufactured roadmaps are really starting to shape out now. And that's both with the traditional OEMs, which of course were a bit later because they had to convert. And of course, all of the new startups, tons of startups happening in China, a lot happening in North America. So the OEM roadmaps are really coming. So all that's to say is that we're really starting to enter the S-curve of EV adoption.
$100 per kilowatt hour. How do we get there? Is it increasing refining capabilities? Is it bringing new mines online? What is it going to take for us to achieve that? Because when you look at the global infrastructure for the critical mineral supply chain, it's very unstable. A lot of it's driven by geopolitics. How can we get there?
I think the first point is that we figured out that lithium-ion storage is good enough. It's good enough to make EVs happen. So I think there's really not much debate there. But it's really coming down to the efficiency, right? It's not only about the minerals and having access, but it's also about the efficiency. So how do we make the cars much more efficient in terms of using less battery? But on top of that, you've seen the battery cost curve decline by over 90% over the last period. So as the technology improves, that's going to be really the mitigating factor. And that's what's going to accelerate both the cost of the battery and then also, as important, the efficiency of the battery. So the battery can last longer.
We have to get the efficiency up. The consumers have range anxiety, and then on the backside, they have charging anxiety. If the battery can become more efficient, in theory, the vehicle can travel farther and they can use destination charging either at their workplace or at their home. As all these new EVs are coming online, I'm going to give you some stats here. In Q3 2022, global passenger electric vehicle sales grew 73% to 2.9 million units. In Europe, EV sales are slowing due to inflation, supply chain issues, but overall, Bloomberg estimates that 10.3 million EVs will be sold globally in 2022. That's a large number of vehicles with 10.3 million EVs coming online alone this year. And you're saying that we have to get to achieve 1 in 50 to get there for 2050. What could be done to upgrade the infrastructure so when an individual walks into a dealership, orders an EV online, they're confident that they're not going to have charging anxiety and the vehicle is going to function properly, very similar to an internal combustion engine?
I think the main point here is that passenger vehicle charging habits will be different than what many people think. And what I mean by that is passenger vehicles are most likely going to charge when they stop versus stopping to charge. Stopping to gas today is the current model. In the future, EVs will charge when they stop. And there's really three reasons for this. The first one is the range, and you mentioned that. As the range of electric vehicles continues to improve, and here I'm on mass market, I'm not on the premium segment where you can have longer range today, but on the mass market, as vehicle ranges increase to 500 kilometers or 400 miles, you start to cover many of the daily use cases. And take, for example, in Europe. In Europe, the average passenger vehicle travels 1,500 kilometers per month. So if you have a range of 500 kilometers, in theory, you only need to charge your car 3 times per month. Of course, that's not going to be the case. In the US, same. The average commute in the US is less than 100 miles round trip per day. So if your vehicle can hold up to 300 miles of autonomy, then that's in theory 3 charges per week. So of course, there's always going to be other cases, but directionally speaking, the range of electric vehicles will allow for charging when you stop. The second one is really on the cost. It's 20 to 50% cheaper to charge when you have a connection to a home or a building than it is in public. And the reason for that is a couple of things. The first one, when you're connecting at home or what we call at work or at destination, such as a hotel or a retail center, you're typically charging on AC or low voltage infrastructure, which is much, much cheaper to install versus DC or faster charging infrastructure. The second point is that you can leverage what we call time of use tariffs, so charging when it's cheaper versus when it's more expensive. You can also avoid demand surcharges. In some countries, in some areas of the world, you have a surcharge if you exceed a certain demand. And you can also leverage on-site storage or on-site photovoltaic or solar generation. So you really have a way to manage when and how much you're paying for energy. And then the third one is really around the convenience factor, right? Today, we don't need to stop unless we're out of gas, and that's a bit inconvenient. Tomorrow, if we can avoid that, of course, as consumers, we're happy. So if we follow this kind of narrative, it means that homes and buildings will be at the center of the charging ecosystem, which means that homes and buildings will need more electricity and more energy management. Now, I'm not saying that we don't need public infrastructure because there's always going to be emergencies. You're going to have the long vacation trip where you're traveling hundreds and hundreds of miles or kilometers. There's going to be use cases for certain jobs like salespeople that maybe need to drive around. But for the majority of cases, we think that charging will happen at home and buildings. Now, in the public, by the way, you're going to pay the price because when you pull off of the highway, you need electricity and you're going to pay whatever the price is. Public charging, we're not able to necessarily manage best time of charging rates because you don't know when you need to charge. You need to charge when you pull over. Now, the last point, which is something that not many people talk about, is really about the skilled labor needed to install all of this infrastructure. So it's one thing to have the technology, and frankly, the technology exists and it's improving. So the technology is there from hardware, from energy management, from software side. But the other bottleneck that's popping up is really the skilled labor. And you have a lot of electricians and installers that do their normal work today, and you have some of them going on the journey to learn how to install things like EV chargers, things like on-site storage, things like photovoltaic. That's not like, wiring a house. That takes a different skill set. It takes a digital skill set that doesn't all exist. So I think one thing to keep our eye on is really the skilled labor set and ensuring that we have the right training and the right labor pool to go out and actually install the infrastructure. I'm less worried that we don't have the technology or the infra available. I'm more concerned that we have the labor pool in place to install those.
The labor pool is going to be key. We're seeing the same thing in autonomous trucking, for example. There's a lack of labor that understands how to align a sensor, how to fix a LiDAR, how to launch an autonomous truck. And that industry has come together and developed a set, if you want to call standards, on how to launch an autonomous truck. Hopefully the same thing happens on EV charging infrastructure, because by 2030, 70% of EV charging is going to happen in commercial, industrial, multifamily buildings. That's a large chunk of infrastructure has to be put in, and that's a very wonderful job set for individuals that are entrepreneurial or want to get the skill sets. How can individuals of multifamily residences, large commercial properties prepare for this? Do they have to put in microgrids? Do they have to start negotiating with utilities now, going through the permitting process to get the electricity? How can they prepare for that?
When we talk about EV charging infrastructure, it's important to understand really where is the value or where's the complexity. And only around half of the value or complexity is visible. And what's visible to most consumers is the charger, because it's physical. You can touch it. You can put your arms around it and give it a hug because you're proud of it, that you have a charger at home. You can do a selfie with it. You also have, of course, your digital interface, which is typically on your phone. Today, there's still some payment terminals and things, but globally, over time, it'll be on your phone. So that's only about half of the complexity. The other half is what you don't see. And what you don't see, first of all, is all of the electrical distribution that takes to get the electricity from the panel board, for example, to the charger. There's safety behind that, AC protection, DC protection, etc., as well as the integration to other systems that are also consuming energy. If we take, for example, a home, when you connect your vehicle to your home, you already are roughly the largest appliance in your home, and you're consuming roughly 50%, depending on the size of service you have, just by connecting your EV. So integration to and having home energy management systems is key, is absolutely key to avoiding outages at home. That's your largest deployment. Now, in buildings, it's the same challenge, just at scale. So today, nobody really talks about integration of EV into buildings because we're connecting 5 chargers, 10 chargers to a small or medium building, not a big deal. But as you start to electrify 100, 500, 1,000, 2,000 parkings connected to a building, well, you better have an integration to what we call building management systems. You better have an integration to the incoming service, because if you don't, of course, you're going to have an outage, you're going to have a problem. And the way we do that is really via energy management. And behind that, you have algorithms that can define how much electricity is available in the home or in the building, and then allocate that to the EV charging, whether it's a single car at home or multiple cars in a building, and then adjust dynamically, right? So as loads come off and on in a building, such as heating, ventilation, air conditioning, and more power becomes available, more vehicles can charge, and vice versa. If there's less power available, then we can send less charging. So I think here the integration to home energy management systems, building management systems is going to be key.
Energy management, for the listeners that might not be familiar with energy management, I'll give you an example. If you walk into a Walmart or a Target or a grocery store for that matter, and you walk down and the lights turn on in the frozen food aisle, that's energy management. It saves those companies a lot of money, and it's very critical because it allows Walmart and the Target and the grocery stores to run their operations. I want to take this one step further here with you, Mike. Do consumers or businesses need to install a resilient power distribution system if they're going to have, say, 20, 30 electric vehicles in an apartment building or a multifamily unit or perhaps a commercial space? Is that another key element that goes into the pie?
Yeah, absolutely. When you install an EV charger at your home or multiple chargers in your building, you do need to revisit the entire electrical distribution and energy management, because you're bringing new loads. You're bringing new loads to your home, and you're bringing new loads to your building. Let's take your home example. Again, EV is your largest appliance, and that's going to be competing for energy with your oven, with your hair dryer, with your heat pump, with your swimming pool, et cetera. So having this integration becomes necessary because utilities don't like to do service upgrades in general. Okay, it's costly and it takes a long time. So upgrading my panel from 125 amp service to 225, for example, or even upgrading my building service takes time and it's expensive. So there's already technology and already tools today that exist that allow us to leverage existing infrastructure. Now, of course, there's going to be cases where we start to electrify bigger than the service and we have to upgrade, but leveraging energy management is a way to avoid those service upgrades.
What's the impact on the energy grid going to be when all these EVs come online? Can the grid sustain it? Are we going to have to upgrade the grid? We'll have to add microgrids, renewable energy. What will the impact on the grid be?
There's a lot of studies on this, and it's interesting. But I would say the first point is that, as you know, we're facing not only a climate crisis, but we're also facing an energy crisis on top of the economic crisis. And that's largely being played out in Europe. So it's no longer necessarily a nice to have. It's more really a necessity. So I don't think that the investments are going to go anywhere. And what we see really is consumers are starting to transform to what we call prosumers. That's producer and consumer. And this journey from being a consumer to someone that both produces and consumes really starts in the garage, and it starts from electric vehicles. And that's really because of cost, of resiliency, and of course of environmental needs. But when you start talking about microgrid or on-site storage at home, this is really a way that we can have grid stability and leverage, of course, renewables, because once you have an EV, you want to use a renewable to charge. You don't want to charge with something coal-fired. You want to use a renewable. So one tool to do that is what we call microgrids. And microgrids can be at home for, again, what we call prosumers, where you're generating solar on the roof. You have a storage capacity at home. You also have your EV car, which can store, and you need to integrate all of that to your panel system and the grid. And again, at scale, at CNI, at commercial industrial buildings, that's the same problem, or the same opportunity, but at scale. And here, there's an example of a project that we did in the US in Montgomery County, where there's a bus depot that has 5.6 megawatts of power generation and 2 megawatts of charging power for their buses, for the bus system. So here you see an example where Montgomery County is moving to 100% renewable. No link to the grid is their goal in the next coming years. So the point here is that we have the technology to make the transition. Yes, there can be an impact on the grid, and it's going to be spotty depending on this neighborhood, that neighborhood, and what connection and how many vehicles. But we have technology to ease that burden and not put everything back to the grid, but be able to absorb some of that on what we call the demand side.
Well, I want to add some numbers to this because Bloomberg New Energy Finance estimates that over the next 3 decades, 119 trillion in spending on energy infrastructure. Pete, 119 trillion in spending on energy infrastructure alone is going to have to happen in order to usher in the net zero goals that we're all working towards achieving. Does bidirectional charging become another solution for that?
It does. And this is, today this is a bit of it's a popular thing to talk about, and you see everybody saying bidirectional, but it really is because your vehicle is basically a moving storage device. So that can be leveraged in many ways. That can be leveraged at home to power your home at night when, for example, you can't generate solar power because there's no sun. But we can also think of other use cases when the vehicles arrive to buildings in the morning after they've been charging at home. You can have 100 vehicles arriving to the office fully charged that could then actually power the workplace for the day. So behind that, by the way, there's a lot of different business models. But yes, I think bidirectional charging is one thing to keep our eye out for the future, something coming soon. You have a lot of conversation in the US, mainly linked to grid resiliency and islanding and being able to, weather storms and outages. So having that vehicle with a battery that can sustain at least some loads in your home for an extended period of time is definitely going to be part of the future. And that's something we need to keep our eyes on for the future.
There's a lot of solutions. Schneider Electric, your world-renowned energy company, how are you approaching the transition to clean energy and electrified mobility? You're clearly leaning into it, but what is the strategy that you're implementing for your clients? You discussed the one in Montgomery where they're going to run off the grid, but how's Schneider leaning into this?
Again, we go back to the technology. Today, most of the technology exists already in order to manage this energy transition and transportation going to electrification. We're providing solutions for our customers, and we really believe that, first of all, everything needs to be connected in order to be efficient, in order to leverage the right tariff, in order to avoid outages. Digital and connectivity is an imperative. So I don't think in the future disconnected charging will really be too prevalent. It'll be there for sure for some use cases, but it's always going to be needed to be integrated at home. And these are solutions that we're providing today: integration of charging to your home energy management system. And again, we talked about that in buildings. We have the same problem, just more at scale. So we first believe everything will be connected. We believe very much in edge control, which edge control means we need to do energy management on site. So whether that's at home, whether that's in a building, we need to have a local edge control. Cloud is great. Cloud cannot do everything. A lot of this technology really needs to be local. And then finally, we can leverage the cloud. We can leverage the cloud for doing a lot of remote monitoring, asset management, restarting of chargers when they're down, and monitoring to make sure that the charging infrastructure is there. So we're really looking at it in several angles, from the products which are connected, local edge control for energy management, as well as cloud connectivity.
Do home energy management systems, so they become the de facto standard for homes of the future if you're building a new home? Okay, we're going to put an air conditioner in. We're going to put heating in. Next step, we better put a home energy management system in because it'll increase the value of our home when we eventually go to resell it. Does that become a standard in the future, do you think?
I believe it will. And when we talk to our customers today, we see a very big demand in the market because up until now, it's been about climate imperative, which is starting to gain some momentum. But now, again, fueled by energy crisis, fueled by storms and outages and grid resiliency in the States, for example, it's really becoming an imperative. So I firmly believe, and we firmly believe at Schneider, and that's where we're investing, that the future is going to be integrated with home energy management systems. It's going to be integrated in buildings with building management systems as well.
What's going to happen to the individuals that live in rural areas? Will they have enough access to energy? Will they be able to enjoy this all-electric future?
Well, rural areas, you'll have a couple of challenges there. One is when you say rural, in the States, that can be many, many, many miles. So people are off. So, I mean, home charging there is going to be an imperative and home charging, but also those consumers will be probably the first prosumers, right? Because they want to produce the energy because they are so far away and they don't have access to necessarily public services in case of emergencies. So they're going to want to produce, they're going to want to store, and they're going to also want, to your point earlier and bidirectional, they're going to want to be able to access the energy in their vehicles. So I believe that for the rural areas, the technology exists, and those are probably going to be some of the earlier adopters in terms of on-site electricity generation from solar as well as storage.
I give an example. You see that microgrids, on-site solar rolling out at farms because some of the farms are 300, 400 miles away from a major city, and they're self-reliant. They're basically self-reliant cities on a small scale because they're self-reliant.
Yeah, exactly. And that's probably more like a microgrid scenario. I've seen the tractors are electrifying. It's kind of cool stuff. And they're autonomous as well, right? So super interesting, but you need power for that. So there out there, you have a bit more space, right? So space is less of an issue. It's not about how much space to have on your roof, but you have a lot of land. So I think microgrids you'll see popping up as well. And you can even think of a farm bit like an island, right? When you're out on an island, you have no connection to the grid. And the farm, of course, you have a grid connection, but you may have higher power needs to your point on tractors, et cetera. So probably it's more of a microgrid scenario, on-site generation and storage in farms as well.
Island's a great example. If you look at the Hawaiian island of Lanai, Larry Ellison bought, he's running it all for renewable energy now. They're relying on bringing in gas to run the generators, and now he's moving towards solar and wind, and he's cleaning up the environment. So it's having a positive impact on that. Electrification will impact all aspects of society. We mentioned farms, islands. If you're going to and from work or going to grandma's house or going to the grocery store, eventually it's going to be done in an electric vehicle. Taking a global approach on this, how should society prepare for an all-electric future?
First point is that COVID was really an awakening. As you saw emissions go down in cities, in Israel, for example, if you're north of Tel Aviv and all of a sudden you can see downtown, you realize, wow, there really is an impact. All of a sudden the Himalayas are visible. So I think the first point is that COVID has awoken a lot of people. Second one is on the recent climate disasters we've been having, storms, outages, shows that the grid is really less resilient. And third, the energy crisis that especially is being felt in Europe is really starting to increase and make a perfect storm in storm of momentum. So I think before it was kind of, thinking we need to do this for the environment, which is great. And we firmly believe in that. But now we're starting to see it's not just for the environment, it's really becoming a necessity. And you've seen, of course, all the investment in ESG following COVID. We talked about the IRA Act in the US that was passed. And in Europe, there's been focus on that for years. So I think that from a society point of view, everybody is now awake in terms of the need for that. Now it's just a question of speed. How quickly can we have the OEM roadmaps deliver the vehicles? Again, technology is there for charging infrastructure. I'm not worried about that. We need to make sure that labor force is there. We talked about that. The labor force is there to go out and install that. And also, I think governments, we tend to focus a lot on public infrastructure. And again, in an earlier conversation, public infrastructure is needed. I'm not arguing that it's not. But the majority of charging sessions are going to be at home and at work, or what we call destinations. So we need to make sure the governments are investing those programs in the right spaces, and not only in public, but also at home and at workplace.
Home is very valid. As we said earlier, 70% of the charging will happen home or workplace. How do we build consumer awareness that electric vehicles, while great for the environment, they're a convenience? You go to sleep, you wake up, your car charged. You don't have to go to the gas station. What could be done to build that consumer awareness? Hey, this is a convenience. This is a really good thing.
Wow, it's like any new technology. You have your early adopters who go and evangelists. And then at the end of the day, I think we just need to go and experience. And for those that haven't experienced an electric vehicle, you can rent them now, and you may even know friends that have them. Take it for a weekend or take it for a week. Just experience it. And I think what you'll find is that a lot of these anxieties that you have aren't really the case. If I take myself, for example, when I first had an electric vehicle, I was obsessed that I would charge it every day. It had to be 100%. Even if I drove 5% of my battery, I was really obsessed. It had to be charged, had to be charged. And then I kind of got used to it and got in the habit that, well, I don't need to charge every day. And for me, I have charging for free at my work. I don't even charge there every day just because I don't need to. I don't necessarily need to have a full charge. So I think that a lot of it's going to come from experience. A lot of it's going to come from who are the people that we trust in our social networks that are telling us that it's okay. So I think there's some education to do, but at the end of the day, it's super basic. Go out, take a weekend, rent an EV. You'll discover it's a pleasure to drive.
They're great to drive. The thing that was not talked a lot about with EVs that I find very fascinating is that Europe is exporting EVs to America. The infrastructure charging really took off in Europe. Norway is leading the world in EV adoption. Europe's exporting electrification to the world from a trend standpoint. Schneider, you're multinational, have operations in France, operations in the United States. What have you learned in your French operations that you're putting into place in America, since Europe has been so far ahead on all things electrification?
Well, I think you're right. I mean, we have a lot of experience in EV charging infrastructure. We actually started investing over 12 years ago, and we invested really extensively. So we invested in different technologies, AC/DC wireless, different geographies, Europe, international, North America. We invested in all of the segments, residential, C&I, public. We invested as well in different business models. So I think one of the key learnings for us, and this is something that we apply everywhere, is really coming back to those charging habits that we talked about. Again, linked to the range of vehicles, linked to the use cases needed to cover those ranges, linked to the cost to charge. Again, 20 to 50% cheaper when you charge at home or at building. So our strategies are really closely linked to our beliefs in terms of where people are going to charge. And that's where we're putting our time and effort to ensure that people are able to charge where we think they're going to need to and want to for the majority of cases.
Your time and effort is well placed. Over the next decade, how do you see this EV market evolving? Do lower priced vehicles come online? Does consumer adoption all suddenly have hockey stick growth and accelerate because of the convenience factor that we discussed?
Yeah, a couple of things I think to watch for. And of course, nobody knows where it's going to go. But first thing, everything's connected. Everything will be connected and everything needs to be open in order to be efficient. My hope is that closed systems will open over time. And we've already seen some of the major closed systems start to at least talk about opening up. So having open infrastructure that's accessible will make it more efficient. Closed systems won't be efficient. And of course, everything needs to be connected. The second one is really, and you mentioned that earlier, on bidirectional. I think that bidirectional is going to be key one in the future, probably starting more in North America and then finding its way eventually to Europe. And the third one are other technologies that are still very much under development, things like wireless charging. We need to see that the economics will play out for wireless charging as they do today for standard plug-in charging. So there's a little bit of work to do there. How do we have OEM adoption? What are the different use cases? So there's a lot of interesting things still to come, I think, in the EV infrastructure space.
There's a lot of interesting things to come, but here we go. What's the future of EV charging infrastructure? We know the home and destination will play a large role. Does it become open interoperable? What is the future, in your opinion, of EV infrastructure charging?
Well, we can imagine, and you know a bit about this, right, regarding AI and autonomous vehicles, right? At some point, we're going to figure that one out. More and more vehicles will be autonomous, whether it's deliveries or at one point, probably passenger. And when we get to more autonomous vehicles, well, the charging is going to change again, right? Because those vehicles aren't really going to sleep. They're going to be operating probably 24 hours, and they're only going to stop when they need to charge. And that's probably going to be done at big depots, probably a little bit outside of cities where you can have some power access and a bit of land. So it will be very interesting to follow this evolution. Once things become a bit more autonomous, how do we charge them? And it'll probably be, again, different than what we're doing today.
Depot charging will play a large critical role in the future of autonomy. Mike, this has been a wonderful conversation where you shed incredible light on all things EV infrastructure, and where we're going. And as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
I think the one takeaway is, if you haven't done it already, go and test drive an EV. Whether you buy it from your friends, whether you buy, rent one for the weekend or whatever, go and drive an EV. And I think a lot of the anxieties that maybe you're feeling today will be resolved just by testing one. So that would be my takeaway. Go try an EV. It's inevitable. It's going to come. You can't avoid it. It's going to be cheaper unless you want to pay more for an internal combustion engine over time. You can, but for most of us, we'll be driving EVs from here on out. So go try it.
As Mike says, go try an EV, drive an EV. It is the future because the future is bright, the future is autonomous, and the future is home destination charging. Mike, thank you so much for coming on the Road to Autonomy today.
Thank you, Grayson.
Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter at Road to Autonomy or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed on this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.